All right, folks, we are looking at practice 521, investigating properties of parallelism and center. This is talking about transformations. You're determining if each of the following transformations represents a dilation. Okay, so a dilation, remember that there are different kinds of transformations. There are rigid isometric transformations. And think of isometric, you think of isometric as, you know, I think of isometric as like when you flex your muscle, you flex your arm, it doesn't move, but you can still engage the muscle. Isometric are rigid. Dilations are not rigid. Dilations are basically, you can think of it as blowing up or shrinking an object, okay? Blowing it up or shrinking the object. So these dilations we want to see. We know it's a dilation if the scale, the growth of each point to its new prime point is the same for each point. Okay, so look at here. We have CMNOP. It's a polygon here. And we want to see if I see. N prime, N prime, O prime, P prime is equal to, or is a dilation. Okay, it's hard, easy for me to say, right? This is a little bit hard to see, but if I look closely, this CMNOP, CMNOP. You see that? Let's zoom a little closer. CMNOP. Okay. Now, prime means that is the image. The prime is after the dilation has happened, after the transformation has happened. So it starts in a smaller shape, and look, it gets bigger. And it looks to me that it gets bigger in the same way. It gets larger in the same way. But here we can't just guess by how it looks. We got to look and see, how did this change? Okay, what was the scale factor that I had to multiply by in order to go from M to M prime? So let's look. If I go from M to M prime, it's 0.2 to 0.4. I multiply a scale factor of 2. So this length, look at this side right here. 0 to 2 is a length of 2. 0 to 4 is a length of 4. Okay, so it's twice as big. The length side CM is 2. Here it's C prime M prime is 4. So a scale factor of 2. So it looks like we have a scale factor of 2. The only thing you have to do to figure out if it is a dilation is look at the other points and how they moved. And if it's also a scale factor of 2, you're good. All right. So look, N is 2.4. N prime is 4.8. So let's see. How do we go from 2 to 4? We multiply by 2. 4 to 8 multiplied by 2. Again, scale factor of 2. Okay. Now we have O here. We have 4, 2. We go to 8, 4. That also is a scale factor of 2, multiplying by 2. 4, 0, 8, 0. That's a multiplying by 2. So it looks like, yes, shape CMNOP and its image C prime, M prime, N prime, O prime, P prime. That shape is larger, and it's 2 times larger. The scale factor is 2. So if my question here is determine whether the following transformation represents dilation, justify your answer, I'd say yes, this is a dilation because all of the points on each of the polygons is a scale factor of 2 larger to go from the pre-image to the image. The image is always where we arrive, okay? The other thing I want to point out here is these tick marks. You can see the 90 degrees. That helps us. We know that vertice P and P prime both have 90 degrees. These double angles here show that this angle is the same as that angle, O and O prime. M, that angle is the same as M prime. And then look here, there's 2 of these tick marks. So M, O, O prime, and M prime are all the same. N and N prime are also the same angles. So just look at these tick marks. They show and tell you. That's going to be important for later in the unit, because we're going to have to match up angles to look at similar shapes here. Okay. All right, let's keep going. So that was number, let's see, that is number, let me just check some real quick. Hello? Where is it? All right. Hello? All right, good. Still recording. It took forever just to find that. Sorry about that. All right, let's see. We had to do 1 through 7 for this. So let's look at comparing. Okay, That's fine. I'm sorry, guys. I got to do something real quick. And I just want to get into the Zoom room again, just in case somebody joins. Jeez, this is really easy. Come on. All right. All right, we're good now. We're going to stop well, I can keep that going. Someone's going to hear me talking if they come in. All right. All right, let's see. Back to what we were doing. Okay, comparing TUV and prime, T prime, U prime, V prime. So triangle TUV and the prime of that triangle. So let's look close. TUV, it looks like it's the larger triangle here, TUV, and the smaller triangle, T prime, U prime, V prime, is in the middle here. So we want to just see, how did we go from, let's look, this one looks easy to deal with, V to V prime. How did we go? Because we know that those angles are the same. So the integrity of this whole shape has stayed the same. We just want to see if it's gotten bigger or smaller. And we'll learn later that similar triangles, if we have angle, 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 we have angle, 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 all in common, we know they're similar. So it is a dilation, but we want to prove it other ways. So look, -6, -3 to -2, -1. How did we go from V to V prime? It looks like we divided by 3, okay? So let's see if that works. If we divided by 3, essentially what we've done is we've multiplied by a scale factor of 1/3, okay? So let's see. If I multiply 9 by 1/3, which is, again, like we said, dividing by 3, let's see. 9 divided by times 1/3 divided by 3 is 3. -3 divided by 3 is -1. You could also think of it as multiplying by 1/3. Here we have -1 to -1/3 is multiplying by 1/3. 3 to 1 is multiplying by 1/3. So yes, this is also a dilation. This is a dilation with a scale factor of a scale factor of 1/3, because the image, the triangle after the translation, is 1/3 the size as your pre-image, your original triangle. Okay, so we're going to keep going with this. These are all the same. So actually, I'm not sure I'm not going to do all of these. Let's jump down, actually. This one, again, would be the same. You know, you're comparing C, which is 0, 0. The image from that, C prime, is on the same spot, 0, 0, because you multiply anything by 0, you get 0. All right? So let's look here. This one, it looks like R and R prime, it was 6, and then it went to 3. So 6, 0 to 3, 0 is multiplying by a half. The scale factor is 1/2. But we look here, look, Q, 0, 8. Q prime then would be at 4. This should be reducing and becoming smaller. This Q, the scale factor, if it's the same as R to R prime, which is divided by 2, multiplied by a half. If I multiply this by a half, I get 0, 4. So this is not a dilation. This is not a dilation because all the points, all the pre-image points, C, Q, and R, they do not all transform in the same way, okay? So this is not a dilation. This would be a horizontal compression, okay? This would be a stretch horizontally, but vertically it doesn't really change at all, okay? So that's the gist for numbers 1 through 4. Now let's just look at 5. Yeah, let's look at 5. Now, one sec. Oh, what's this? I'm going to pause it for just a moment.